Hi, this is Ravikant. Welcome and welcome back to the channel. So today we have some basic concept of an arithmetic progression. In this video we will learn that what is an arithmetic progression and how can we solve it. So get ready to learn some interesting concepts about an arithmetic progression. And without further ado, let's start the video. First we will see that what an arithmetic progression exactly is. So an arithmetic progression is a sequence of numbers in which the consecutive terms are formed by adding a constant quantity with the preceding term. Means a series will always an arithmetic progression if the difference of the term and the preceding term means the next term is always same or constant. Here we will set the constant quantity as common difference, which is denoted by D. Next heading we have the common difference CD. So the common difference is the amount between each number in an arithmetic sequence. It is called common difference because it is the same or common to each number and it is the difference between each number in the sequence. Means we always get the same or common value when we subtract the preceding term from the previous term. So we go through some basic examples that illustrate about the common difference. So here is our first example. So I subtract the preceding term which is 1 from the previous term which is minus 2. Then I get the common difference 3. Now 4 minus 1 which is also equals to 3. Same 7 minus 4 which is also equals to 3. So we always get common term 3, that means the given series is an arithmetic progression with common difference 3. So that's how we can check the series that it is an arithmetic progression or not. Next we have another example. We will do the same as we have done in the previous question. So subtract the preceding term which is 23 from the previous term which is 11. Then we get the common difference 12. Now 35 minus 23 which is also equals to 12. Same 47 minus 35 which is also equals to 12. So we get 12 as the common term that defines the series is an arithmetic progression with common difference 12. So finally we can easily calculate common difference by subtracting the preceding term from the previous term. And that's how we can also check either the given series is an arithmetic progression or not. So next we have, if the nth term is given, then how can we find whether a sequence is an arithmetic progression or not? So we have an algorithm that will determine whether a sequence is an arithmetic progression or not when its nth term is given. So what is the algorithm? So the algorithm is divided into 3 steps. In first step, we will obtain an, which is nth term, that is already given in the question. In second step, we will replace n by n plus 1 in the nth term to get an plus 1, which is our preceding term. And in the final step, we will calculate the common difference by subtracting the preceding term an plus 1 from the previous term an. Now we have two conditions. When an plus 1 is independent of n, then the given sequence is an arithmetic progression. And if an plus 1 is not independent of n, then the given sequence is not an arithmetic progression. So to check out whether the given sequence is an arithmetic progression or not, we will go through some examples. So this is our first example. In this example, we have to show that the given sequence an is equals to 2n plus 3 is an arithmetic progression. Also, we will find out the common difference. So we have the given sequence an is equals to 2n plus 3. Now replace n by n plus 1. Then we get the following equation. After further solving, we get 2n plus 5. Here 2n plus 5 is the preceding term. Now we calculate the common difference which is given by an plus 1 minus an. So put the value of these terms. After further solving, we get an plus 1 minus an is equals to 2. This is our common difference. So the equation is independent of n, means it does not consist of n. So the given sequence is an arithmetic progression. Now let's move on to the next example. In this example, we have to show that the sequence an is equals to 3n square plus 2 is not an arithmetic progression. So we have the given sequence an is equal to 3n square plus 2. Now replace n by n plus 1. Then we get the following equation. After further solving, we get an plus 1 is equals to 3n square plus 6n plus 5, which is the preceding term. Now we calculate the common difference, which is given by an plus 1 minus an. So put the value of these terms. After further solving, we get an plus 1 minus an is equals to 6n plus 5, which is our common difference. So the equation is not independent of n, means the given sequence is not an arithmetic progression. So that's how we can calculate whether the given sequence is an arithmetic progression or not. Next heading, we have the general form of an arithmetic progression. The general form of an arithmetic progression is given by a plus d, a plus 2d up to dot dot dot. Here a is the first term and d is the common difference. Then the nth term of an arithmetic progression is given by a plus n minus 1 into d. If you think where this term comes from, then we go through a proof. Because proof is the only thing with the help of that things become very easy. So let's assume a1, a2, a3 dot 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 up to an. So we can calculate the common difference, which is given by a2 minus a1 is equals to d. Let's assume a1 is equals to a and put the value of a1 in the above equation. Then we get a2 minus a is equals to d. Taking a to the right side, then we can write a2 is equals to a plus d. Now from next two terms, we can calculate the common difference. a3 minus a2 is equals to d. Taking a2 to the right side, then we get the following equation. We know the value of a2 is equals to a plus d. So put the value in this equation, then we get a3 is equals to a plus 2d. Just for the simplicity, we can write a3 is equals to a plus 3 minus 1 into d. Similarly, from the next two terms, we can get the common difference. a4 minus a3 is equals to d. After putting the value of a3 in this equation, then we get a4 is equals to a plus 3d. We can also write a4 is equals to a plus 4 minus 1 into d. This pattern will run up to the nth term. By following the same procedure, we get the nth term, which is equals to an is equals to a plus n minus 1 into d. So we can write the general term, which is given by the following equation. So this is the proof which will help to remember things to solve the related questions. Next, we have the nth term of an arithmetic progression from the end. So what do you think what it can be the nth term from the end? Let's assume a is the first term and d is the common difference. Let's consider an arithmetic progression which consists of m terms. Then the nth term from the end is given by m minus n plus 1 term from the beginning. It means if you want to find the nth term from the end, then find m minus n plus 1 term from the beginning, instead from the end. So we can calculate the nth term of the end, which is given by a plus m minus n plus 1 minus 1 into d. So what we have done? We just put the value of m minus n plus 1 in the formula of nth term of an arithmetic progression. So the nth term from the end is given by a plus m minus n into d. Next heading, we have the arithmetic mean. So when there are three quantities given which are in arithmetic progression, then the middle one is known as the arithmetic mean of the other two. So take an example which illustrates the arithmetic mean. In this example, we have given three terms. So the arithmetic mean is the middle term, which is 22. In next example, the arithmetic mean is 9. And in the last example, the arithmetic mean is 6. To make things become very easy, we will go through the proof so that we can understand easily. Let's assume m is the arithmetic mean of these three quantities. So the common difference will be equals to m minus x is equals to d. This is our equation first. Similarly, y minus m is equals to d. This is our second equation. These equations are equal because these are equals to d. So that we can write m minus x is equals to y minus m. After further solving this equation, we can write m is equals to x plus y by 2. Means the arithmetic mean between any two given quantities is the half of their sum. So next we have the arithmetic mean between the extreme terms. Means if we have a long arithmetic progression, then what will be the arithmetic mean between the extreme terms? Here extreme terms are the first and the last term of the given arithmetic progression. So take an example. In this example, the extreme terms are 3 and 35. So the arithmetic mean is defined by the each term which lies between these extreme terms. So these values are the arithmetic means. In next example, the extreme terms are minus 5 and 19. So the arithmetic means are the each term which lies between these two extreme terms. So we can easily calculate the arithmetic means between the extreme terms. So in this video, we have learned these following topics of an arithmetic progression. I hope you understand these topics. In next video, we will learn about the following topics which will come very soon with some exciting concepts. So thanks for watching our video. If you like this video, then give a big thumbs up to the video. If you want to see more videos, then keep watching our videos. Till then, stay healthy and keep training your mind.